Ladies and gentlemen, Team ER presents to your attention a research proposal on brain fog in symptomatic individuals with diabetic condition after recovery from COVID-19. I am Benji Cohen in the Washington, D.C. area.
My name is Clayton Reed. I'm from the San Francisco Bay Area.
I'm August Phelps. I'm from the D.C. area.
I'm Frank Sheffield from right here in the D.C. area.
My name is Mitchell Petrov, and I'm from Brooklyn, New York.
So the question we aim to address through our proposal is whether type 2 diabetics who have recovered from a COVID-19 infection have increased microvascular damage and cognitive function deficits compared to healthy individuals. A few points by way of background research. As you all know, COVID-19 is a global pandemic that's already affected over 15.5 million people as of today. A grasp of the long-term neurological implications would be key to determine how much care might be needed for patients who've recovered from coronavirus. Patients with COVID-19 sometimes experience stroke as their first symptom, which indicates a link to vascular damage in the brain. Finally, the number of COVID-19 survivors anecdotally reporting prolonged brain fog after recovery is on the increase, making it critical to study this subjective experience. Brain fog is a state of diminished mental capacity, and it involves somewhat of an inability to think clearly, reduced awareness, and trouble paying attention. To be clear, it is not a disease, it's just a catch-all term for a range of many vague neurocognitive problems. Patients who've recovered from COVID have exhibited many neurologic manifestations, including memory lapses, MRI abnormalities of the hippocampus, hallucinations, delusions, compulsions, depression, suicidal behavior, confusion, reduced coordination, Guillain-Barré syndrome, and post-infectious encephalitis.
In terms of what we know that the ACE2 receptor, which is expressed in the brain as well as many other tissues, is the target of the SARS-CoV-2 virus, similar to its predecessor. Patients with diabetes who are predisposed to neuroinflammation overexpress the ACE receptor, and in general, they have a higher risk and are 1.34 times more likely to suffer microvascular damage. Diabetics are the ideal study group to explore the neurological effects of COVID, as COVID is suspected to target this microvasculature, and given that diabetes has a higher presentation of microvascular abnormalities, this makes them the ideal study group. The current data suggests there is a link between severity of infection and diabetes, as the prevalence in a New York hospital between March and April of diabetes was 15% overall, whereas in hospitalized cases it was 31.8. And Italy followed a similar pattern with non-complicated cases having only a 6% diabetes prevalence, whereas in complicated non-ICU and ICU cases, it was much higher at 24 and 32% respectively. In regards to what we know about the ACE2 receptor, it's found all throughout the body. It's found in the lungs, heart, kidneys, intestines, brain, and testicles. And the pathway to the brain, for the purpose of our study, would be the cribriform plate of the ethmoid sinuses. ACE2 expression, as mentioned, is not equal in all people, and in fact is overexpressed in diabetes, which may lead to complications. In terms of access point, the ACE2 is attacked by the S1 spike protein of the SARS-CoV-2 virus.
So, the impact of diabetes on the microvascular structure and neuroinflammation. As we all know, everything within the body works on a cause and effect basis. If you change one thing, it will inevitably affect something else within the body. So there's no question that inflammation is inherently linked with diabetes, but the inflammation is oftentimes stemming from inherent damage to the microvascular structure. Let's talk about how that damage is caused. One of the leading causes of that damage is within the microvascular structure on a cellular level. It happens between the conversion of glucose to glucose alcohol, or better known as sorbitol. When someone has high glucose levels or an influx of sugar molecules throughout the polyol pathway, it causes a high sorbitol concentration. This high concentration causes osmotic stress and then leads to microvascular damage. The inflammation that we often associate with patients with diabetes is seen with an influx in 3 cytokines: CD4, CD8, and CD20. So let's talk about neuroinflammation. Microglia are the focal point for any discussion with neuroinflammation. And this is because it is the innate ability of the immune cells to perform the primary immune surveillance throughout the production of cytokines. The use of cytokines usually is used as a response initiated to protect the central nervous system from any infectious agent. But there's no infectious agent. It can be toxic, and it can even have an effect on the leukocytes throughout the blood-brain barrier, and that can affect cognitive abilities. So let's connect it all together. If patients with diabetes have microvascular damage, which causes inflammation, and COVID-19 causes more inflammation because it is an infectious agent itself, it could cause the inflammation to be severely more prevalent and have greater effect on diabetic patients. This puts them at risk.
So what don't we know? We don't know exactly which neurocognitive functions are impaired by post-COVID-19 brain fog. We're also uncertain as to whether brain fog is related to microvascular damage in the brain, a direct attack on the brain tissue by COVID-19, or some combination of the two working together. We also, while we know that many symptoms of COVID-19 are more severe in diabetic patients, we aren't sure if this applies to microvascular damage as well. So our study is seeking to answer the last two of those questions.
Let's discuss our hypothesis and both of our sub-questions. What is the effect of COVID-19 on the microvasculature of the brain and cognitive function? And is this more severe in type 2 diabetic individuals? We hypothesize that type 2 diabetic individuals will evidence more severe cognitive and microvascular impairments than those without pre-existing neurological conditions. Are changes in either cognitive function or microvasculature as measured by MRI reflected in pathology from non-surviving type 2 diabetics with COVID-19? We hypothesize that the microvascular changes measured on MRI as well as cognitive impairment will be in line with the neuropathologies observed in non-surviving type 2 diabetics with COVID-19.
Our proposed methods and measures for the study are documented in this procedural diagram, which I'm going to walk you through. So the process of the study begins by sampling two very large cohorts of around 5,000 patients, all over 18. One group with no pre-existing neurological conditions, and the other group with only type 2 diabetes. Those two groups should be as similar as possible in terms of age and ethnic distribution. And the first step of the study will be to gather some baseline cognitive and microvascular data from both groups upon enrollment. Cognitive function will be assessed by a standardized battery of tests. The microvascular data will be gathered using a FLAIR MRI, which is the most sensitive protocol for detecting white matter hyperintensities. To quantitatively assess the amount of white matter hyperintensity, which can be a marker of microbleeds and microvascular damage, the total volume of hyperintensities in the entire brain will be measured. All the MRI data will be blinded to avoid any bias on the part of the radiologists reading it. At that point, patients will be followed for a year, and those who develop a symptomatic case of COVID-19 and recover from it during the period of observation will be retested for the same metrics that were taken at enrollment. Any patients who contract COVID during the study and don't survive will have neuropathology performed to determine their level of microvascular damage as a method of validating and supporting the MRI findings. Once the study is complete, preliminary data and post-COVID data will be compared between the diabetic and non-diabetic groups to determine whether there are any statistically significant differences in the magnitude of new damage to the microvascular system and brain overall. At the end of the study, data from any participants who didn't contract coronavirus and from anyone who developed unrelated neurological conditions will be discarded to avoid any confounding. Also, patients in the study can choose not to have neuropathology performed in the event they don't survive COVID, and that wouldn't preclude them from the rest of the study. Now, the reason here for this large sample size is because only a minority of the people will actually get COVID over the course of the study. And the reason for a cohort study is because we need to attribute the effects on the brain only to COVID to the greatest degree possible. We don't want to misattribute anything.
So let's look at some dialectical considerations. So our study does have some limitations. Our proposed study design is extremely ideal and will be quite difficult and complex to execute as a result of the massive number of participants who will be receiving MRIs and cognitive tests. This large number of MRI recipients for the non-essential purpose of our observational study could also be difficult to allocate in a time of crisis where there are many people needing MRI scans due to illness that are more urgent. Also, with so many participants to track, there is a higher likelihood of a methodological failure occurring somewhere within the study. And in addition, it's entirely possible, and I mean, it could be hopeful, that the severity of this pandemic could drastically decrease during the study period, which would lead to a sample size that is too small and would invalidate our results.
As we previously stated, the experimental design is extremely ideal, so we have to take a look at the arguments and refuted findings. So by gathering a baseline set of data at the very start of our experiment, we attempted to assure that most of the neurological effects of diabetes were separated from those of COVID. One thing we would have to consider is the disease progression in diabetics between the enrollment and infection could slightly impact our results. Another thing we have to consider is, since any changes that occur between the baseline and the post-infection follow-up will be attributed to COVID, this could cause us to accidentally link some neurological progressions of diabetes to the neurological progressions of COVID. So we have to consider the length of time that patients are being studied have had diabetes previously. Lastly, as the hypothesis loosely states, that more pre-existing neurological damage from diabetes would correlate with a greater amount of newly found damage from COVID. So we estimate that the duration of diabetes will likely have a strong positive correlation between the severity of cognitive impairment and microvascular damage. This data would be essential to gather from patients to stratify our results. And it even could lead to additional questions like, would people who get COVID twice experience worse neurological problems the second time around due to existing damage? And how would COVID affect those with autoimmune diseases like lupus or Crohn's who are already predisposed to inflammation?
Given that we've said all this, let's now talk about our anticipated and potential findings. So our anticipated and potential findings are largely predicated on diabetics' predispositions to microvascular damage and the effects of COVID on that microvasculature. So we expect to see greater degrees of new microvascular damage and cognitive impairment in diabetics than non-diabetics that have recovered from COVID-19. And we expect to link the severity between cognitive impairment and degree of microvascular damage as visible on the MRI scans. However, there are two situations in which this may be problematic. A finding of only worse microvascular damage in diabetics could potentially imply subclinical damage that is not evident in cognitive testing. On the other hand, a result of only worse cognitive impairment in diabetics might reflect undetectable microvascular or a completely different mechanism of action on the brain by the COVID-19 virus.
There are several ethical, legal, and social implications associated with this study. The ethical implications include a possible negative view and stereotyping of recovered COVID patients, especially diabetics. If the hypotheses were confirmed, people in the media could seize the headline that post-COVID patients are neurodeficient, particularly diabetics, causing a wrongful, damaging conclusion to spread and potentially resulting in harassment and neurotyping. Additionally, African Americans might be more represented in this study than in other biomedical research, since they're at a greater risk of both type 2 diabetes and COVID-19. Unfortunately, the risks of the study might also hit them harder. The study is accompanied by significant risks, as sending participants to the hospital for the initial MRI and cognitive test increases their chance of contracting COVID-19. Returning patients for their post-COVID follow-up also involves the potential for a hospital-acquired infection. However, the benefits, which include increased public health awareness as a result of the attention from conducting such a large study, a greater understanding of the overall neurological effects of COVID, particularly in type 2 diabetics, and general knowledge of how SARS-like viruses affect the central nervous system, which would be useful in the event of a future pandemic, do definitely outweigh the risks.
So our study also comes with some legal implications if our hypotheses were proven correct. There is possibility for discrimination against post-COVID individuals. It brings up the question about professional errors in individuals who have recovered from COVID-19 but still have reduced cognitive function and how that affects their life in the workplace. There's also possible medical malpractice ramifications. Doctors working on the front lines right now are especially likely to become infected through their high exposure rates. And take, for example, if a surgeon or anesthesiologist contracted COVID-19 and recovers, but is then experiencing brain fog and makes a mistake that severely harms a patient, who is going to be held responsible for that? And does this leave hospitals open to lawsuits? Lastly, there's the idea of the use of COVID-19 as a legal defense. In the same way that people sometimes use, my brain made me do it, could delusion, memory lapse, or confusion due to post-COVID brain fog be used to argue for a reduced sentence?
It is absolutely imperative that we don't overlook the social implications here. If our null hypothesis is rejected, it could severely heighten health disparities. This is because minorities are disproportionately affected by both COVID and diabetes. And a finding of more severe damage in diabetics would only make the gap for minorities even larger. Another thing we would have to consider is our entire educational system. Students could present with varying degrees of brain fog, and then we would have to take into consideration how these individuals specifically would have to be taught. Frankly, I think it would have to be in new and innovative ways.
Ladies and gentlemen, thank you for your time. We wanted to personally thank Dr. Giordano, Dr. Wartzman, Morgan, Nezo, and Justine. We also wanted to thank Leadership Initiatives for this amazing opportunity that they presented for us. Thank you very much.
My pleasure.
Thank you guys so much. I'm going to bring in our judges.
Well, before I pass this on over to our esteemed panel of referees, I actually have to ask Group ER a question. And it's not a rhetorical question, it's a real question. You guys want a job? Outstanding. This is a word I don't use too often in this context, but wow. With that said, I'm going to pass the reins on over to Dr. Wertzman, and we'll go through our panel of referees. Rachel, over to you.
Bravo, guys. I told you, this seminar, this was at the level of a first-year graduate seminar. You guys did a phenomenal job. Your level of thinking about the LC issues, about the experimental design, about the limitations, about the real-world actual implementation of this was extremely sophisticated. It really was. And the depth of your background knowledge, the degree to which you synthesize all that information, look, it is not a simple matter to go through and connect these really divergent tasks in a coherent, cogent way that argues for your study. It was a creative study, making the argument that you know, by comparing healthier individuals to people with pre-existing diabetes, that you might actually get to see those an exaggeration of the effects of COVID-19 and therefore get to an answer of what it's doing in the brain faster. I mean, that was just brilliant, guys. I am so proud of you. There are a couple minor things that, you know, we talked about a little bit before. You really did a great job getting to the synthesis in your background fast, and then it sort of seemed to bring in some details that were a little bit less relevant, and then you came right back in with your connecting the dots statement, which is really spot on. I think you probably could have trimmed out a little bit of that in there, which also might have helped your length and the pacing of it overall. I think the clarity might have just been a little increased by swapping the anticipated findings and the dialectics. If something I communicated actually prompted you guys to swap that around in some ways, I apologize. I'm changing my mind, but I really think I might have said it would be better in the other direction. But you know, it was a great script. You know, if you guys had more time, the one thing that you'll notice you will get better as you go along in this field is when you're presenting, you get a little bit better at talking to the audience like you're just communicating a little bit less. The goal is to sound like you're not reading a script. So you start with a script and then you get to the point where you're really just communicating to people. And so I have no doubt that you guys will increase with that skill over time, but I promise you, Dr. Giordano does not say that as a first comment very often. He means it. I'm extraordinarily proud of the work that you guys have done here. Thank you.
Thank you.
Professor Shook, over to you, sir. Muted. You're muted.
Congratulations. Agree with everything that was just said and more. It's hard to pick out one thing to especially encourage you further. You know, especially in philosophy, go by the principle, know what you know what you don't know, and your presentation was clear and detailed and practically confessional about what you don't know, what are the known unknowns and some of the potentially unknown unknowns. It seemed like with every other slide, it was again sophisticated and exploratory, but without being naive or vague. So congratulations. And on the ethics side, I really appreciated the exploration of some of the social, some of the real world, some of the educational implications of possible findings. So great work. Thank you very much.
Very good. Ms. Kiarian, over to you.
Thanks, guys. I could watch that all day. Seriously. I hope to get the recording just to replay it constantly. So I'm going to talk as a medical scribe, and I'm going to talk as a student. So as a medical scribe, to start out, I work with COVID patients. I've seen COVID brain, not just in diabetic patients, but in a lot of different patient populations. And it's very scary, but I think you guys really touched upon something that's really important, in that it's really hard to disentangle how complicated things get. People have a lot of different comorbidities. They live in a lot of different environments. Some people are homeless. Some people are coming from out of state. So I think the way that you talk about how complicated it is, and it's not just a simple cause and effect, that there are a lot of different factors when it comes to clinical presentations of brain fog with diabetic patients, is really important. So addressing that and addressing that you didn't know, you don't exactly know all the factors that are at play, are really, really important from a clinical standpoint. As a student, I think it's really awesome to see you guys presenting in a clear way, but also, again, admitting that by answering or asking one question, you're opening yourself up to a whole slew of things that you don't know. And I think a lot of students tend to oversimplify things and pretend that they know what no one else really knows. And you guys were very, very good in being clear that these are the things that we know and that we're curious about, but we don't pretend to know everything. So that was fantastic.
Excellent. Herr Professor Dr. Kohls.
Well, the critical German has to say that was outstanding. I mean, I could really see it in your faces that you have fallen in love with the topic. And so one could see it in your eyes. The presentation was outstanding. I liked the way you switched roles, you alternated, one came back and then hands and forth. That was good. Also, the slides looked good. A minor thing, you presented some graphs, and I'm not sure if you have produced these graphs by yourselves, and I missed the source.
Yes, I did. I did it in Pages. I just exported it as a PDF.
Oh, okay.
It as an image. I used arrows and boxes.
Uh-huh. Just write own copyright also. It is clear that you haven't copied it from elsewhere. And additionally, I can only say, I mean, the content is just timely. This is I mean, I'm a medical psychologist working in health promotion. This is really a very, very timely and also very, very hot topic, I can assure you. And I mean, a lot of questions spring to my mind. For example, diabetes type 2 is frequently associated with an unhealthy lifestyle. So obesity is a big issue, for example. I mean, that in case things turn out the way you actually presented them, it could easily be that this would have a lot of consequences for the insurance system. And I wonder, one of the questions I wondered about is why was it that you have restricted your research to type 2 diabetes? And why haven't you chosen type 1 diabetes, for example, which is not lifestyle related?
So we took in the U.S. The prevalence of type 2 diabetes is much higher. So
Yeah.
part of it is that we thought it would apply to more people in the year.
Yeah, it would allow us to get all our test subjects if we were in a pinch for that and stuff like that. So it was just a more overall population, and we didn't want to constrict ourselves to that.
Yeah, along with that, you mentioned it. I mean, it's associated with an unhealthy lifestyle. We sort of know where type 2 diabetes comes from. Type 1 is still sort of enigmatic for us in the medical field. So type 2 is definitely easier to study in that sense.
Very good.
Very nice. Very nice. Very good.
Thank you, Professor.
I'm impressed.
Ms. Lovelace, to you.
Hey guys, fantastic job. Time and concept, agree with what everybody said so far. Love, love, love your slides. Excellent mix of clarity, organization, stylish design. I want you guys on my team when I'm doing my slides. Audio level was great. Everyone presented themselves appropriately. Great eye contact. The only minor thing I could pick, if I was gonna pick something, is just make sure your faces are lighted so I can see you when you're speaking. And again, it's just the new technologies, learning how to handle all of these different factors. It's one thing to straighten your tie and get up on stage where you're already lit, you already look great, but this is a little different. And I'm learning, everybody's learning how to use this new technology. So just that would be that's the only thing I can think of to suggest. Everything was fantastic. Great job.
Oh, thank you very much.
Thank you.
So let me speak to that also. This is new technology. This is a new venue, a new nexus for how we're going to interact. And I think it's here to stay for a number of reasons. As Professor Coles will tell you, a lot of our work over the years has used this as the format and the vector for our affiliation, our collaboration. And I think people are getting more comfortable with it. But I did something a little different. This is the presentation itself was stellar. The topic was right on, very, very timely. In many ways, cutting edge. I mean, you're proposing a set of experiments that I think need to be done. And, like they say in the movies, we should talk after. I'm not kidding. But what I did was I closed my eyes at one point and I wanted to see if your discourse was able to carry me through the complicated information without doing what I usually do, which is being a very visual learner. And it did. So what you were able to do is you took very complicated information that you presented on your slides and you made it very, very sentinel and very salient to someone who would be coming at it from a variety of different levels. Very, very well done. Not easy to do, and I commend all of you. Bravo to you all. Rounds of applause.
Amazing job.